In just 72 hours, the universe seemed to unfold a sequence of events so improbable that it almost felt scripted. The sky erupted with light, the Earth trembled with force, and from the depths of interstellar space, an alien visitor was struck by the breath of our own star. It was a cascade of moments that left scientists astonished and the public unsettled. Was this nothing more than coincidence, or was there a hidden pattern at play? Chaos or code picture yourself in the southern hemisphere before dawn. You step outside into the cool night air and you notice something strange. In the familiar canopy of stars, a new light has appeared. It is not the slow crawl of a satellite nor the sudden streak of a meteor. It is steady, unwavering, as if a new star has been born overnight. Then, just as observers begin to take notice, another appears days later, in a different constellation just as bright. To the human eye, these were stars that had not been there before. To astronomers, they were nova's sudden explosions on the surfaces of white dwarf stars visible to the naked eye because of the sheer violence of their outburst. The first was Nova 1535 Centauri, discovered on the 23rd of September, 2025, shining at magnitude 5.8. In the quiet hours before sunrise, it became a new pinprick of brilliance in the constellation Centaurus. Almost immediately, instruments around the world detected its fury. The Fermi Space Telescope picked up gamma rays, the Swift Observatory recorded hard. X-ray signatures of particles accelerated to near the speed of light. Just days later, as if one was not enough, a second nova was confirmed. Nova V7994 Sagittari burst into visibility in the constellation Sagittarius, reaching a magnitude of 6.2. Two novas of this brightness appearing within days of each other is exceptionally rare. On average, the Milky Way may host 10 or 12 novas each year, but only a handful ever grow bright enough for the human eye to see. For two to flare almost simultaneously was the astronomical equivalent of lightning striking twice in the same place. While the southern sky was flaring with explosions light years away, the Earth itself began to shudder. In the state of Zulia in northwestern Venezuela, the ground convulsed without warning late on the night of the 24th of September. At 22 hours, 21 minutes, coordinated universal time seismographs registered a magnitude 6.2 earthquake at a depth of 7.8 kilometers. The shaking was strong enough to rattle buildings from Maracaibo to Caracas, strong enough to send chandeliers swaying and residents rushing into the streets. Only hours later, at 3:51 in the morning on the 25th, a second blow struck. This one measured magnitude 6.3, slightly deeper at 14 kilometers, but close enough in location to overlap with the earlier rupture. Two significant earthquakes in the same region within such a short time is not unheard of, but it is unsettling, as if the Earth itself delivered a 1-2 punch before pausing to catch its breath. By now the list of events seemed uncanny. Two novas visible to the naked eye, two major earthquakes in Venezuela, all within a span of 72 hours. But the sequence was not finished. In the solar system, the sun was at the height of its activity cycle. Bursts of magnetism arched through its corona, and one of them tore free in a colossal eruption. A coronal mass ejection, a cloud of plasma billions of tons in weight, raced into the inner solar system. Monitored by the Space Weather Prediction Center of the National Oceanic and Atmospheric Administration, its trajectory was plotted with precision, and in a remarkable coincidence, the model showed the CME cutting across the path of a newly discovered interstellar visitor, an object named 3I Atlas. 3I Atlas is not just another comet or asteroid. It is the third confirmed interstellar object ever detected, a traveler from beyond the Sun's domain, flying a hyperbolic orbit that carries it through our system and back out into the galactic night. By late September 2025, it was threading its way across the plane of the solar system between Mars and the Sun. That was the very moment when the solar storm unfurled, sweeping directly across its path. Humanity had never before witnessed a coronal mass ejection interacting with a body from another star system. The idea that this chance visitor could be struck by the fury of our own sun at the height of its cycle, felt almost staged. Put the pieces together, and the picture is staggering. In less than 3 days, the universe seemed to deal 4 dramatic cards. 2 novas erupting light years away but suddenly visible to human eyes. 2 earthquakes cracking the crust of Earth within hours of one another. A coronal mass ejection, a storm of charged particles hurled across millions of kilometers of space. And through it all, an alien object, a messenger from the void, flying headlong into the storm. Each of these events taken on its own is explicable by science. We understand why a white dwarf ignites, why tectonic plates shift, why magnetic fields reconnect and fling plasma into space. But happening all at once in the span of 72 hours, they strike the human imagination as more than chance. They feel like cosmic dominoes toppling in sequence one after another, each amplifying the sense of unease. This is the tension we face. On the one hand, science teaches us to resist connecting dots without evidence. On the other hand, our minds are wired to seek patterns. When 4 extraordinary events occur so close in time, we ask ourselves whether the universe is merely chaotic, or whether there is a deeper code written into its fabric. Are we simply unlucky witnesses to a week of wild coincidences, or are we being reminded in ways we can barely comprehend of our fragile place in the cosmos? As we move forward, we will step through each of these events in detail. We will see the novas for what they truly are, dying, stars flaring with borrowed fuel. We will feel the earthquakes not as abstract numbers but as lived moments of fear and survival. We will ride the solar storm as it lashes out from the sun, and we will follow 3i Atlas, the interstellar wanderer, as it drifts through the tempest. Only by understanding each piece can we decide whether this chain of events was chaos without meaning or a hidden code written in the stars. But for now, let us return to that first astonishment, the sudden bloom of light in the night sky. How is it possible that 2 novas rare to the point of improbability could appear so close together, both bright enough to be seen without a telescope, both within the same extraordinary week? A new star appears in the sky. To the human heart, it feels like a miracle, a sign, perhaps even a divine gesture. But to science, it is something far more violent. A nova is not the birth of a star, but the sudden detonation of one that should have been quiet, a nuclear furnace reigniting on the surface of a dead sun. A new point of light that did not exist the night before is not magic. It is a hydrogen bomb on a cosmic scale. In the early hours of September 23rd, 2025, before the sun climbed above the horizon, an amateur observer named John Seach scanned the southern sky from his home in New South Wales, Australia. He had done this countless times before. For decades he had risen before dawn, searching the heavens for changes so subtle most eyes would miss them. That morning he spotted something different. Near the constellation Centaurus, a star glimmered where none should have been. He measured its brightness at magnitude 5.8, just faint enough to twinkle on the edge of naked eye visibility, but undeniable. Within hours, reports streamed in across networks of astronomers. They confirmed what he had seen, a nova later designated V1935 Centauri. Almost immediately, the space-based instruments that keep watch over the high-energy universe came alive. The Fermi telescope recorded gamma rays streaming in from the coordinates of the new light. Swift another orbital observatory slewed into position and caught the burst of hard X-rays. These were the signatures of particles flung to nearly the speed of light protons and electrons, whipped into fury by magnetic fields and shock fronts. What Seach saw as a faint new star was in truth a thermonuclear flash across space, a white dwarf tearing loose the hydrogen it had stolen from its companion star and igniting it in a runaway blaze. That alone would have been extraordinary. On average, our galaxy sees perhaps 10 or 12 novas each year. Most are faint detectable only by professional telescopes or CCD surveys. Only rarely does one climb to the edge of naked eye visibility, and when it does, it captures headlines across the world. Yet only a few days later, the impossible seemed to repeat itself. Before the astonishment of Centauri had faded, Seach again caught sight of a suspicious brightening this time, in the constellation Sagittarius. Another star that had not been there before, another nova. This one was catalogued as V7994 Sagittarii, and it flared to magnitude 6.2, again faint but visible to those who knew where to look. To casual stargazers it seemed like a new jewel sprinkled onto the southern Milky Way. To astronomers it was a cosmic cannon shot a second nuclear detonation, arriving so soon after the first that disbelief spread quickly across the community. 2 novas of near naked eye brightness appearing within days of one another is a staggering coincidence. In the past decade, only a handful of such bright novas had been seen at all, and they were separated by years. To have 2 appear in the same week is like witnessing 2 supervolcanoes erupt on Earth within days. Not impossible, but so rare as to feel like a message from the stars. For those living under the southern skies, the spectacle was immediate. Step outside at night, and you could see them yourself, faint sparks that had not existed before. Imagine standing on the dark plains of Argentina or the beaches of Australia and looking up. Among the endless spray of the Milky Way, a new light gleamed, defying memory, insisting on its presence. To human eyes, which have charted the heavens for millennia, with almost religious reverence, such a change is unsettling. The constellations are supposed to be eternal. Yet here they were shifting before our gaze. The scientific explanation does not lessen the drama. A nova is born when a white dwarf, the burned-out core of a once sun-like star, clings to a living companion. It pulls hydrogen from the larger star, siphoning its life in a quiet theft that can last centuries. Over time, that hydrogen piles up on the white dwarf's surface until it reaches a critical pressure and temperature. At around 100 million degrees Kelvin, the hydrogen ignites in a runaway reaction, fusing explosively into helium in a blast that releases more energy in days than the sun emits in years. The star does not die. It survives to repeat the cycle like a bomb that resets itself, ready to explode again when enough fuel accumulates. So when Seek spotted V1935 Centauri, he was not witnessing the creation of a star, but the reawakening of one long dead. A stellar corpse that had stolen fuel from a neighbour and erupted in a thermonuclear fit. And when V7994 Sagittarii followed days later, the pattern was uncanny. 2 corpses exploding 2 zombie suns, announcing their presence with nuclear fire. To put this in perspective, if the entire Milky Way were a dark plane at night, a nova is like a sudden flare gun fired into the air. It is bright, shocking, and temporary. Within weeks, sometimes months, the new star fades again, leaving only the memory of its light. But in those days of brightness, human beings cannot help but assign meaning. Ancient Chinese astronomers called such appearances guest stars and recorded them meticulously. In medieval Europe, they were seen as omens of change or doom. Even in the age of science, when we understand the physics of runaway thermonuclear burning, the emotional weight remains. To see a star ignite where none existed is to feel the universe remind us that nothing is permanent. For modern astronomers, these novas were not only dramatic but valuable. Networks such as the American Association of Variable Star Observers mobilized quickly. Telescopes across wavelengths from optical to radio swung into place to record spectra. Hydrogen lines broadened by high-velocity outflows, helium peaks and heavy elements appeared all clues to the conditions of the blast. As days passed, observers reported fluctuations in brightness, possible dust dips as material condensed and veiled the light. Each nova is a laboratory, teaching us about binary star evolution, nuclear physics under extreme conditions, and even the acceleration of cosmic rays. Yet for the public, all of that detail condenses into a single fact: 2 new stars had appeared in the heavens in the same week. The poetic imagination cannot resist a comparison. It is as if 2 enormous cannons had been fired into the galaxy, shells of light exploding across the sky. The southern hemisphere seemed suddenly alive with celestial artillery, the cosmos itself reminding us of its firepower. And so, while one hemisphere of Earth looked up in awe, another part of our planet was about to tremble in fear. Because even as the novas burned in Centaurus and Sagittarius, the crust of Venezuela began to crack. But before we turn to the quakes of Earth, let us linger a little longer on the novas themselves because they are more than passing curiosities. They are signals from deep time messages carried across thousands of years finally arriving in our skies. The light that reached John Seach's eyes on that September morning did not leave Centaurus yesterday or last year. It had been travelling for centuries, perhaps millennia. When V1935 Centauri exploded, civilizations on Earth may have still been young empires rising and falling, whole eras passing before its light ever brushed against our world. By the time we noticed, the explosion was long over the white dwarf already fading back into obscurity. What we witnessed was a ghost, the afterimage of a cataclysm that had already passed. The same is true for V7994 Sagittarii. Its outburst might have occurred when Europe was in the Middle Ages or when ancient astronomers were mapping the skies without telescopes. We cannot yet know the exact distance, but we know the principle. Every nova is a time capsule, a flicker from a remote past arriving at just the moment we're here to see it. 2 of those capsules opened in the same week, filling the southern sky with echoes of long-vanished fury. And these were not silent events. The eruption of a nova is not a gentle swell of brightness. It is a roar of particles and light. Gas is hurled outward at thousands of kilometers per second. The shock fronts accelerate electrons to energies high enough to produce synchrotron radiation. Gamma rays and X-rays testify to conditions so extreme they border on the unimaginable. For astronomers who tuned their instruments, this was a bonanza, a chance to test theories, to refine models of binary star systems and the physics of thermonuclear runaway. Yet to the human imagination, stripped of instruments and jargon, they were simply new stars, pinpricks of brilliance defying the permanence of the constellations, and because they were rare, they carried weight. If only one nova of this brightness appeared in a year, it would already be a headline. But 2 in a week invited speculation, wonder, and unease. People asked if they were linked, if some wave of cosmic influence had triggered them both. Scientists cautioned that there was no evidence of connection. Each nova had its own binary system, its own local conditions, its own trigger point. Probability alone allowed for them to occur together. But the warning did little to still the sense of strangeness. It is in our nature to connect events. We see patterns in the clouds, faces in the shadows, meaning in the roll of dice. So when the night sky unveiled 2 novas in quick succession, our minds did what they always do. We asked, what does it mean? And we felt, even without reason, that it must mean something. Imagine explaining this to someone centuries ago. Imagine standing in ancient China or medieval Europe and pointing to a new star in the sky. It would be read as a sign from the heavens, a harbinger of fortune or disaster. Entire dynasties believed their fates were written in such lights. And now, in the 21st century, even as we wield gamma-ray telescopes and particle physics, the same ancient shiver runs down our spines. The novas remind us that the universe is alive, restless, unpredictable. To grasp the scale, let us compare. The energy released in a nova may equal the output of our sun over tens of thousands of years, all compressed into days or weeks. The outflow of gas can spread across billions of kilometers. The shock waves can seed interstellar space with heavier elements, enriching the clouds from which new stars and planets will form. Every nova is both a death cry and a gift, scattering the materials that someday might become worlds, oceans, and life. So when 2 novas appear side by side in the same month, we are not just seeing explosions, we are seeing the processes that build galaxies, the recycling of matter on a cosmic scale. 2 cosmic cannons firing into the void, their shells scattering the seeds of future stars. For those lucky enough to look up, the effect was unforgettable. In the dark skies of rural Chile or the outback of Australia, observers whispered in disbelief as they pointed out the new lights. Children traced them with their fingers. Amateur astronomers sketched them into their charts. Online forums filled with excitement as images poured in from telescopes great and small. Even through the grainy blur of backyard optics, the novas shimmered like messengers insisting that the heavens are not fixed but alive. It was a moment that revealed both the fragility and the wonder of our perception. We imagine the stars as eternal, yet they change. We imagine the sky as silent, yet it roars. And in that week of September 2025, it roared twice. But as the novas continued to burn, another kind of roar began to rise much closer to home. The ground in Venezuela groaned, shifted, and finally snapped. Buildings swayed, people fled into the night, and the earth reminded us that chaos is not confined to the heavens. The novas were beautiful, but beauty can be deceptive. Because a nova is not merely a light show. It is a time bomb that resets itself, a warning that even dead stars can still surprise us. And just as we began to marvel at their glow, we were about to discover that their beauty carried a darker truth. Novas are not only fireworks. They are slow-ticking bombs scattered across the galaxy, ready to erupt again and again. A star can die yet not be buried. It can lie dormant for ages, cold and diminished, until one day it flares back to life. Not as the steady glow of rebirth, but as a violent outburst, a resurrection more terrifying than hopeful. Imagine a corpse clawing its way out of the grave, not to live again, but to explode in fury. That is a nova, a zombie star rising from the dead. When you picture a star, you probably imagine something like our sun, steady burning, giving warmth and light for billions of years. But most stars do not end with such calm. When a sun-like star exhausts its fuel, it sheds its outer layers and leaves behind its core a white dwarf. A white dwarf is one of the strangest objects in the universe. It has the mass of the sun crushed into the size of the Earth. Picture something as heavy as all the planets combined, but no larger than the world beneath your feet. The density is staggering, about 1 million grams in every cubic centimetre. To put that in perspective, a teaspoon of white dwarf matter would weigh as much as an elephant. For most white dwarfs, this is the end of the story. They cool slowly over trillions of years, fading into black cinders. But if a white dwarf is paired with a companion star, the story takes a darker turn. Like a vampire, the white dwarf begins to siphon gas from its neighbour. Hydrogen, the simplest and most abundant element, flows across the gravitational bridge between the two stars, settling on the surface of the dwarf. It does not mix in. It does not ignite right away. It piles up, growing denser and hotter under the relentless weight of gravity. At first, nothing seems to happen. The white dwarf sits in silence, gathering stolen matter like a miser hoarding coins. But inside, pressure builds. Hydrogen is squeezed into layers so dense that the atoms themselves are forced closer together than they ever would be in ordinary conditions. Temperatures rise to tens of millions of degrees. And then one day the balance tips. At around 100 million degrees Kelvin, the hydrogen undergoes runaway thermonuclear fusion. In just a few seconds, the entire layer ignites like a sheet of gunpowder. The star detonates. This runaway blast is what we see as a nova. The explosion can release as much energy in a matter of days as our sun produces over thousands of years. To an observer on Earth, it appears as a new star, a sudden light in the darkness. But it is not new at all. It is the resurrection of a corpse, a flash from a stellar zombie that refuses to stay dead. Imagine standing on a world orbiting near such a system. First you would see the companion star bright and steady. Then, without warning, the dwarf beside it would ignite, blasting plasma outward in all directions. Gas would roar into space at speeds of thousands of kilometers per second, enough to circle the Earth in under a minute. A sphere of burning hydrogen would envelop the system, spreading outward into interstellar space. The sky would be filled with ribbons of glowing plasma, curling and stretching like fiery wings. Even from light years away, this chaos reaches us. Through telescopes, we can dissect it. The spectrum of a nova tells us what it is made of. At first, broad hydrogen lines dominate, stretched by the speed of the outflow. Helium joins in, followed by the heavier elements forged in previous stellar lives. Over time, as the gas expands and thins, forbidden lines appear, features that can only exist in environments so diffuse and low pressure that atoms radiate in ways impossible on Earth. These spectral fingerprints let us measure the speed of the outflow, the temperature of the gas, and the violence of the explosion itself. To scientists, this is a laboratory written across the sky. To the rest of us, it is a miracle of horror and beauty combined. The idea of a zombie star may sound like metaphor, but it is closer to reality than you might think. The white dwarf is not truly alive. It has no fusion of its own, no internal fire. It only exists because of its theft. Without a companion to feed from, it is inert. But when it drinks from its partner's life, it wakes again, and that waking is catastrophic. The nova is its scream, a cry of stolen vitality released in fire. The scale of the blast is difficult to comprehend. Our sun, steady and constant, radiates energy that sustains all life on Earth. Multiply that output by 1,000 years, compress it into the span of a week, and you will approach the violence of a single nova. From our perspective across the void, it is a flicker of light. From the perspective of physics, it is an atomic firestorm consuming everything it has stolen. And the white dwarf survives. Unlike a supernova which tears a star apart completely, a nova leaves the core intact. The blast is only the hydrogen layer flung off like a skin shed in rage. The dwarf remains hungry, still ready to begin again. This cycle can repeat endlessly, each eruption separated by decades or centuries. It is not death. It is undeath, a pattern of eternal recurrence that turns these stellar remnants into true cosmic zombies. Through spectroscopy, astronomers can watch the story unfold in real time. At first, hydrogen lines blaze, stretched and broadened by shock waves, racing outward at thousands of kilometers per second. Then helium appears, followed by the fingerprints of heavier elements. As days pass and the gas expands, forbidden lines emerge, signatures of atoms radiating in conditions so tenuous they could not exist anywhere on Earth. This tells us not only what the nova is made of, but how it evolves. The light curves, the dips and peaks in brightness, are like the pulse of a dying monster, first flaring, then faltering, sometimes reviving for one last gasp. To picture it, imagine a corpse not lying still, but rising again and again, sucking the blood of its companion, swelling with unnatural vigour, and finally exploding in a convulsion that shakes the galaxy. That is what John Seach and astronomers across the world witnessed in September 2025. Not one, but two such resurrections flaring in Centaurus and Sagittarius within days of each other. These events are not only spectacles, they are cosmic engines of change. The gas flung into space becomes part of the interstellar medium, the raw material for future generations of stars. The carbon, oxygen, and nitrogen released enrich the galaxy, seeding the clouds, from which new worlds will one day form. A nova is destructive, but it is also creative. It kills, but in killing it plants the seeds of life. In that sense, even zombie stars contribute to the eternal cycle of death and rebirth that defines our universe. And yet to human imagination they remain terrifying. The thought that the stars above us are not fixed but volatile unsettles the mind. We look for constancy in the heavens. We want the night sky to be a map that never changes. When novas appear, they remind us that the cosmos is unstable, restless and alive. They remind us that even the dead can rise again, and that their rising comes not in peace but in fire. If a nova can unleash the energy of 1,000 years of sunlight in days, what of a supernova? That is the darker cousin of this story, the true death of a star, a detonation so fierce it can sterilize worlds across light years. Every nova carries within it the whisper of that possibility. Because if a white dwarf grows too massive, if it feeds too much, it can cross a threshold, the Chandrasekhar limit, about 1.4 times the mass of the Sun. At that point, the nova cycle ends. There will be no more small resurrections. Instead, the star will collapse and detonate in a supernova, an explosion bright enough to outshine entire galaxies. So when we look at novas, we are not only seeing fireworks, we are seeing warnings. The white dwarf survives each eruption, but it is climbing toward a cliff. One day it may fall, and its fall will be catastrophic. This is why astronomers rush to record every detail of V1935 Centauri and V7994 Sagittari. They were not just curiosities. They were laboratories, clues to the physics of matter under unimaginable pressures, clues to the fate of binary stars across the Milky Way, and perhaps clues to the ultimate future of our own sun's descendants. To the public, they were jewels in the sky flashes of wonder. To science, they were undead stars, bombs that detonate again and again, each time scattering fragments of their story across the void. And as these novas burned, as their light travelled across centuries to find us in that fateful week, another story was beginning closer to home. On Earth itself, the ground was preparing its own convulsion, a chain of tremors that would remind us that chaos is not only written in the stars, it lies beneath our feet as well. When the heavens burned bright, the ground answered with a roar. It was as if the universe had decided that the drama would not remain confined to the stars. It would come down to Earth into the homes and lives of ordinary people in the dead of night. Picture the city of Maracaibo, Venezuela, on the 24th of September 2025. The day had ended like so many others, humid air drifting in from Lake Maracaibo. The streets still restless with traffic and conversation. Families had gone to bed, ceiling fans humming overhead, children curled against their parents. It was a night like any other, until at 22 hours and 21 minutes, universal time, the ground buckled. First came a deep groan like the earth clearing its throat. Then a sharp jolt through open cupboards rattled glass panes and sent furniture skidding across tile floors. Lights swung in widening arcs, shadows leaping across walls. Dogs howled, car alarms shrieked, and people poured into the streets in their pajamas, clutching children and cell phones, unsure whether the shaking would stop or intensify. Seismographs later recorded the event as magnitude 6.2. Its hypercenter lay just 7.8 kilometers beneath the surface, shallow enough for the shock to rip through concrete and steel with terrifying immediacy. In Maracaibo, the shaking toppled decorations, cracked plaster, and sent chandeliers swaying as if pulled by invisible hands. Farther east in Caracas, the capital hundreds of kilometers away, the tremors still rippled through high-rises, waking thousands in confusion. Across the border into Colombia, the quake was felt as a long, unsettling sway like the deck of a ship caught in a slow swell. On the ground, numbers mean little. What people remember are the sounds and the fear. The rumble underfoot like a freight train passing just below the floor. The creak of beams straining against forces they were never meant to endure. The crash of dishes, the thud of books, the shouts and prayers rising from stairwells as residents fled downward, desperate to reach the open air. For many it was not the first quake they had known, but it was among the strongest. The shaking lasted less than a minute. Then came the silence, heavy and strange. Streetlights flickered. Neighbours gathered in clusters, speaking in quick bursts, counting heads, scanning buildings for cracks. Social media filled with videos of lamps swinging of walls, trembling of frightened faces illuminated by the glow of cell phone screens. The collective thought was the same. Thank God it is over. But it was not over. Just 5.5 hours later, when people had begun to settle back into uneasy sleep, the earth struck again. At 3:51 in the morning on the 25th of September, the second earthquake hit. This one was magnitude 6.3, only slightly stronger than the first, but deep enough at 14 kilometers to feel different, more rolling than jolting. Yet for those already on edge, the second blow was devastating. Imagine the psychological impact. You survive a major earthquake, spend the night outside, or finally creep back into bed telling yourself the danger has passed. Then, just before dawn, another shockwave ripples beneath you, stronger than the last. Walls groan again, windows rattle, and the terror you thought you had outrun comes rushing back. It was as though the earth itself had transformed into a boxer in the ring, landing one punch, pausing, then delivering another to the same bruised target. The epicenters of the two quakes lay close together near the oil-rich region of Zulia. This was not random. The geology of Venezuela is complex, a patchwork of tectonic plates grinding and colliding. The Caribbean plate presses against the South American plate, and the fractures that lace the Maracaibo Basin are prone to stress. When the first quake struck, it redistributed the pressure underground, transferring it to adjacent faults. Hours later, that pressure gave way in the second quake. To scientists, this was a classic example of stress triggering. To residents, it was a nightmare that would not end. Reports came in from across the region. In Maracaibo, apartment buildings swayed, water tanks sloshed over, and staircases echoed with the pounding of feet as tenants fled. In smaller towns, cracked walls revealed thin threads of daylight where concrete should have been solid. Schools and hospitals reported minor damage but remained functional. Remarkably, the death toll was limited. Modern building codes, lessons learned from past tragedies, had prevented the worst. Yet fear spread faster than damage. People wondered if a third quake would strike if the cluster was only beginning. Scientists compared the energy release of the two events. Magnitude is logarithmic, which means that a 6.3 releases nearly twice the energy of a 6.2. Combined, the pair equaled the force of a quake around magnitude 6.5. The comparison helped quantify the violence, but it did not calm nerves. For the people living through it, the numbers were irrelevant. What mattered was the sense that the ground had turned against them, striking with fists of stone in the same vulnerable spot. It was an echo of ancient stories of a world alive and angry. Cultures throughout history have described earthquakes as the footsteps of gods, the thrashing of subterranean beasts, or the wrath of spirits buried deep below. In Venezuela, where colonial churches and modern towers stand side by side, some prayed, some cursed, some simply waited in dread. The timing made the events more unsettling. They coincided with the novas flaring in the sky and the sun's restless storms. Scientists were quick to insist there was no connection. Earthquakes are driven by tectonic stress, not cosmic radiation. The novas were thousands of light years away, the solar eruptions millions of kilometers. But for ordinary people, the clustering of disasters felt like more than coincidence. 2 new stars, 2 quakes, all within days. It was enough to make pattern-seeking human minds whisper of hidden meaning. In the days that followed, aftershocks rippled through the region. Most were small magnitude, 4 or 5, but each was enough to set people on edge. Every vibration of the floor, every sway of a light fixture reignited the memory of those 2 larger shocks. Psychologists call it seismic anxiety, the lingering fear that grips communities long after the earth has gone quiet. Children clung to parents. Grandmothers refused to return to upper floors. Families camped in open plazas, unwilling to trust their homes. Geologists worked quickly to analyze the sequence. They mapped the hypercenters and noted the alignment with known fault systems, particularly the Bocono and Ocaancon fault zones that run through the Maracaibo Basin. The depth differences between the first quake at 7.8 kilometers and the second at 14 suggested stress was migrating downward through the crust. It was not supernatural, not cosmic, but mechanical rocks snapping and grinding as they redistributed their load. And yet, even as scientists explained the mechanism, the metaphor of 2 punches refused to fade. It was a vivid way to describe what had happened, and it matched the lived experience. The earth had struck twice in succession with enough force to leave the region reeling. Like a fighter in a ring, the planet had jabbed and then delivered a heavier blow, daring its opponent to remain standing. For the global audience following the events, the coincidence with the novas was irresistible. News outlets ran stories linking the starbursts with the earthquakes, sometimes carelessly suggesting a connection. Social media buzzed with speculation memes and fear. Was it possible, some asked, that cosmic events had stirred the Earth's crust? Was this the beginning of a larger pattern, a chain reaction stretching from the heavens down to our fragile ground? Scientists countered with clarity. There is no known mechanism by which a nova thousands of light years away could trigger an earthquake on Earth. The gravitational influence is negligible, the radiation diluted to invisibility. Even the coronal mass ejections of the Sun, powerful as they are, interact mainly with our magnetosphere and technology, not the shifting of tectonic plates kilometers underground. The quakes were coincidences, part of the natural rhythm of a restless planet. But the timing was uncanny. In less than 3 days, humanity witnessed 2 novas and 2 quakes. The brain wired for pattern recognition struggles to accept chance in the face of symmetry. 2 lights above, 2 shocks below. It was enough to make many pause to wonder if there was meaning hidden in the chaos. In Caracas, journalists interviewed residents still shaken from the night. One woman described how her apartment building swayed glasses crashing from cupboards, children screaming as they scrambled for the stairwell. Another man told of the eerie silence after the first quake, broken only by dogs barking in the distance, and then the renewed panic when the second hit before dawn. It felt, he said, like the earth was alive, like it wanted to remind us who is in control. Elsewhere, officials reassured the public. Emergency crews inspected bridges, highways and hospitals. Engineers declared most structures safe, though cracks and cosmetic damage were common. The government issued statements emphasizing resilience. But beneath the calm words, people knew the truth: earthquakes are unpredictable. No one could say with certainty whether the cluster had ended. The Earth, after all, does not follow human schedules. Stress builds silently over decades or centuries, then releases in seconds. The Maracaibo Basin has a history of seismic unrest, its faults grinding as the Caribbean plate presses westward. What happened in late September was not unprecedented. But coming at the very moment when the heavens themselves were in turmoil, it felt like part of a larger storm, a chorus of chaos reverberating from sky to soil. To stand outside that night was to feel suspended between two realms of danger. Above Novus flared light from dead stars long past finally reaching our eyes. Below the crust groaned energy stored for centuries breaking free. Humanity caught in the middle could only watch and endure. The twin blows of Venezuela were a reminder that catastrophe does not always announce itself with grand scale. Sometimes it comes in repeated strikes smaller than apocalyptic but large enough to scar memory. 2 quakes each, powerful, arriving within hours. For the people of Zulia, they were not statistics. They were lived reality moments of fear etched into walls and minds alike. And so, as the dust settled and the aftershocks faded, a question lingered. Were these twin earthquakes nothing more than the ordinary release of tectonic stress? Or were they part of something larger, a pattern that tied the trembling of Earth to the upheaval of the skies? 2 blows only hours apart. That is how the people of Venezuela will remember those nights in late September. The ground struck once, then struck again, as though the planet itself had chosen to fight. But why? To understand, we must look deeper into the Earth, into the mechanics of stress and release, and place this event within the larger history of seismic disasters that have scarred human memory. History tells us that great earthquakes often arrive not alone but in clusters. Consider Lisbon in the year 1755. On the morning of November 1st, as citizens filled churches for All Saints' Day, the ground convulsed. The quake itself is estimated at magnitude 8.5 to 9.1 of the largest in European history. Within minutes, fire consumed the city. Within an hour, a tsunami surged into the harbour. But what many forget is that Lisbon did not suffer one event alone. Aftershocks rocked the region for weeks, spreading terror as survivors tried to rebuild. Each tremor, no matter how small, reawakened the fear that the catastrophe was beginning all over again. Or think of Pompeii, buried in 79 AD by the eruption of Mount Vesuvius. Archaeologists now know that years before the volcano's final explosion, a powerful earthquake had already shaken the region. Walls cracked, aqueducts shifted, statues toppled. The people repaired what they could, but the warning had been given. The quake was a precursor, a reminder that the earth rarely moves just once. Its heart beats irregularly sometimes with devastating rhythm. Against this backdrop, the Venezuelan cluster of September 2025 takes on sharper meaning. The first quake magnitude, 6.2, at a depth of 7.8 kilometers, was powerful enough to jolt Maracaibo and Caracas. The second magnitude, 6.3 at 14 kilometers, followed only hours later. To scientists, the sequence was not mysterious. It was a textbook case of stress transfer. When one fault ruptures, it does not simply end the story. It redistributes the forces underground, loading adjacent segments with new strain. Rocks that were balanced on the edge of failure are pushed over that edge. In this case, the first quake altered the stress field in such a way that the second became almost inevitable. The Earth did not simply choose to strike twice, it was compelled by its own physics. The logarithmic nature of earthquake magnitude deepens the picture. A difference of 0.1 on the magnitude scale does not mean a trivial change. Each step represents roughly 32 times more energy released. A 6.3 therefore unleashes almost twice the energy of a 6.2. Together, the two Venezuelan events equaled a single quake of about magnitude 6.5. For the residents who lived through both, it felt like enduring one great blow interrupted and then resumed like the pause between punches in a fight. The cluster did not end there. On the 25th of September, after the second major shock seismographs, registered an aftershock of magnitude 5.88. By itself, that would have been a significant earthquake capable of damage and fear. In this sequence, it was categorized as an aftershock, a smaller echo following the main events. Its timing and size fit neatly into a pattern described more than a century ago by the Japanese seismologist Fusakichi Omori. Omori's law states that the frequency of aftershocks decreases over time in a predictable way. Strongest soon after the main quake, they diminish, gradually tapering off like the fading reverberations of a drum. Venezuela's sequence followed this rule with chilling precision. What felt like chaos to those above was in fact order written in the language of geology, yet scientific explanation does not erase emotional reality. To live through a quake cluster is to feel the Earth's heart falter. Each tremor is a skipped beat, each aftershock a flutter that raises the question, is this only an echo, or is the main event yet to come? That is why survivors so often describe the Earth as alive, its rhythms uncertain, its temper unpredictable. The Venezuelan quakes were not the largest in history, but they carried that same unsettling rhythm, the sense that the planet's heart was beating out of time. To visualize this, imagine a drum skin stretched tight. Strike it once, and the vibrations spread across the surface. Strike it again in just the right place, and the resonance intensifies, amplifying the sound. The Earth's crust behaves similarly. One rupture sets off vibrations that travel shift and sometimes trigger another rupture nearby. What seems like coincidence is in fact resonance. The cluster is not random. It is the Earth's way of redistributing its stresses, of finding a temporary balance in an endless dance of pressure and release. But the timing of Venezuela's quakes cannot be ignored. They coincided with two novas flaring in the sky and with a restless sun hurling plasma into the solar system. Scientists insist correctly that there is no causal link. Stars exploding thousands of light years away cannot shake the ground beneath our feet. Solar storms can disturb satellites and power grids, but not tectonic faults buried kilometers deep. And yet the human mind resists such separation. When the heavens burn and the earth shakes in the same week, we reach for connection. We weave meaning into coincidence. We whisper that perhaps the cosmos itself is trembling above and below. In this, the Venezuelan cluster becomes part of a larger narrative. Two novas, two earthquakes, four shocks, two from the stars, two from the ground. For those who lived it, the symmetry is haunting. For those who study it, the message is simpler but no less profound. The Earth is not static. Its heart is erratic. Its pulses can come in quick succession, leaving us fragile on its restless surface. And as Venezuela steadied itself, another force gathered. For while the ground was shifting beneath our feet, the sun above was preparing its own assault. Its magnetic fields twisted, its corona erupted, and plasma surged outward. The Earth's quakes were dramatic, but they were not alone. The star that gives us life was entering one of its most chaotic moods. They say a sneeze is harmless, a reflex of the body clearing itself. But when the sun sneezes, the whole solar system feels it. One violent exhalation from our star can send waves of plasma racing outward, strong enough to fry satellites, disrupt power grids, and collapse the internet on which global civilization now depends. Imagine a single star shaking its head, and the echo of that motion bringing modern life to its knees. The event is called a coronal mass ejection, or CME. To picture one, imagine the surface of the Sun, a boiling ocean of plasma arcs of magnetism writhing like serpents. Tangles of magnetic field lines twist tighter and tighter, storing energy like a wound spring. Then, in a moment of reconnection, the spring snaps. Plasma superheated and electrified erupts in a colossal surge. From the Sun's corona, a bulge of incandescent matter swells, breaks free and hurtles into space. Its tendrils can stretch for millions of kilometers, red ribbons coiling in vast spirals. To the eye it looks like fire. To physics it is billions of tons of gas moving at hundreds to thousands of kilometers per second. The scale is almost impossible to grasp. A single CME can release as much energy as billions of hydrogen bombs. Its speed ranges from 250 kilometers per second at the slowest to over 3,000 at the fastest. At such velocities, a CME can traverse the distance from the Sun to Earth in just 1 to 4 days. When it arrives, it does not strike like a rock. It envelops us in an invisible storm of charged particles that buffet our planet's magnetic shield, forcing it to bend, compress, and sometimes shudder violently. For most of human history, such storms passed unnoticed. The aurora borealis and aurora australis, those curtains of green and red light in polar skies, were their most visible signs. But in the modern world, we have laced the planet with wires, satellites and networks. Now the Sun's sneezes have consequences. A major CME can induce electric currents in power lines, overheating transformers and blacking out cities. It can jam radio communications, degrade GPS signals, and push satellites into premature descent as the upper atmosphere swells with heat. The same event that once made only a spectacle of auroras could now darken continents. We know this because it has happened before. In September of 1859, a British astronomer named Richard Carrington sketched an enormous flare from the Sun. Hours later, telegraph systems across the world erupted with sparks. Operators reported being shocked papers catching fire, and messages still transmitting even after batteries were disconnected. It was the first recorded solar superstorm now known as the Carrington event. If such an eruption occurred today, experts warn the damage to global infrastructure would be catastrophic. And the Sun is restless once again. Solar activity waxes and wanes in cycles of roughly 11 years. At the peak, sunspots proliferate, flares intensify, and CMEs become frequent. In late 2025, the Sun will be near the maximum of its 25th cycle. Already the 10.7 centimeter radio flux, a measure of solar activity, hovers between 180 and 190 solar flux units, a sign of heightened energy. Dark sunspots pepper the solar surface, their magnetic fields, thousands of times stronger than Earth's. Around them, arcs of plasma leap and coil like hair on a static charged head. There is another factor, the time of year. Twice annually near the equinoxes, the geometry between Earth and Sun favours stronger magnetic coupling. Known as the Russell-McFerran effect, this alignment means that even moderate solar storms are more likely to cause severe geomagnetic disturbances. In other words, September is a dangerous month. It is the season when the Sun's storms most easily breach our defences. So when the novas flared and the Venezuelan ground convulsed, the Sun added its own spectacle. A CME burst outward, captured by spacecraft and modelled by the Space Weather Prediction Center of NOAA. Analysts tracked its trajectory through the heliosphere, projecting its path across the inner planets. And that path astonishingly intersected not just Earth's neighbourhood, but something rarer still, an interstellar visitor. The third ever confirmed object from beyond our solar system, 3I Atlas, was in the line of fire. Before we turn to that extraordinary encounter, let us dwell a moment longer on the image of a CME itself. Imagine standing near a volcano as it erupts lava fountains rising into the sky. Multiply that by 1 billion, replace molten rock with plasma hotter than any earthly furnace, and stretch the eruption across a canvas as large as the Sun. The CME is a cosmic volcano without a mountain, an explosion painted directly onto the face of a star. It is not a projectile so much as an expanding cloud, a sphere of charged particles spreading outward, filling the interplanetary medium with turbulence. Auroras dance at Earth's poles as the solar wind collides with our magnetosphere. Satellites shiver, currents surge, and astronauts shelter behind shielding as radiation levels spike. To us the storm is invisible, but its effects ripple through technology and sky alike. It is as if the sun reminded us with every sneeze that we are not separate from it, but bound, tethered by magnetic ropes across 93 million miles. And now, for the first time in history, one of these solar sneezes was predicted to sweep directly over an object not born of our system, a wanderer from the stars. The prospect electrified astronomers. For centuries we have studied comets, asteroids and planets within our sun's domain. Never before had we watched our star's fury collide with something that came from beyond. It was a natural experiment on a scale no laboratory could match. The sun had sneezed, and the galaxy itself seemed to lean in, waiting to see what would happen next. As the CME billowed outward, instruments traced its progress through the solar wind. Its velocity, close to 1,000 kilometers per second, meant it would reach Mars in just over 2 days. Earth was not in the direct line of fire, but the shock wave still brushed our magnetosphere, causing subtle fluctuations in geomagnetic indices. For scientists at the Space Weather Prediction Center, this was routine work, yet this time the routine carried an extraordinary twist. The path of the CME intersected with the trajectory of 3I Atlas, the interstellar object discovered only months earlier. 3I Atlas was already a source of fascination. A hyperbolic orbit revealed its origin beyond our sun, its angle steep and retrograde compared to the planets. It was no mere comet or asteroid from the Kuiper Belt. It was a messenger from another star system crossing our domain for the first and only time, and now, just as it approached the inner solar system, it would be tested by our star's rage. Scientists speculated about what they might see. In 2007, the comet Encke's tail had been severed by a CME captured in dramatic images by the Stereo spacecraft. The shock of the solar wind had sliced through its ion tail, leaving it momentarily decapitated before a new tail formed. If such an event could be recorded for a local comet, what might happen to an interstellar visitor? Would Atlas flare in brightness as its coma was bombarded with energetic particles? Would its ion tail twist and snap under the onslaught? Could traces of its composition be revealed as solar plasma stripped molecules from its surface? For astronomers, this was a once-in-a-lifetime opportunity. No laboratory on Earth could simulate such conditions. To watch an interstellar object collide with the solar wind was to watch a cosmic experiment play out in real time. Networks of telescopes were alerted. Amateur astronomers were urged to photograph Atlas night after night, hoping to catch subtle changes. Professional observatories prepared spectra to detect carbon, oxygen, or other volatiles in the wake of the CME. The event underscored the sun's dual nature. To us it is life-giver, the steady warmth that makes Earth habitable. But beneath that calm face lies a monster. Its surface seethes with magnetic storms. Its corona is a battlefield of arcs and loops fields twisting until they break. The CME is the scream of that hidden violence, a blast that crosses millions of kilometers to remind us of our dependence and our vulnerability. The image often used is that of a beast exhaling. Imagine a dragon, its mane flaming, sneezing out a plume of fire that stretches for millions of kilometers. The sun's filaments are its hair, its plasma tongues are its breath, and the solar system lives in the constant danger zone of its cough. At the peak of cycle 25, late in 2025, these storms are not rare but frequent. Sunspot numbers are higher. Radio flux hovers around 180 to 190 solar flux units, and each week brings fresh eruptions. The Earth's technology trembles with every major flare, yet we adapt, shield and watch. We cannot prevent the sneezes of our star. We can only predict them, endure them, and learn from them. And so we watched as this CME tore across the void toward a target we had never studied before. The interstellar stranger, 3I Atlas, was about to be baptized in solar fire. Would it survive unscathed, drifting on its hyperbolic path as if nothing had happened? Or would it reveal hidden layers, fragments of its ancient past peeled back by the storm? The answer lay ahead in the coming days as telescopes captured its every move. For humanity, the significance was immense. For the first time, we would see our sun's breath collide with matter from another star system. A sneeze, yes, but a sneeze powerful enough to shape science, to expand knowledge, to remind us of the reach of our star. A sneeze that tied together the heavens and earth, the familiar and the alien, in a single storm of plasma. And the timing of it all was uncanny. 2 novas erupted in the southern sky. 2 earthquakes cracked the crust of Venezuela, and now the sun had erupted, blasting an interstellar visitor in the same 72-hour window. Coincidence or code, chaos or a hidden pattern. One thing was certain for 3i Atlas: the journey through our solar system was no longer quiet. It was about to become the first alien object ever struck by the fury of our star. A stranger wandered into the battlefield, and it did not belong here. The sun had erupted plasma arcing outward in colossal streams, magnetic fields snapping like whips across millions of kilometers. And into this storm drifted a body not of our system, a traveler from beyond the reach of the sun's dominion. 3i Atlas had entered the line of fire. It was like a ghost ship straying into a war zone, silent, solitary, and utterly exposed. The story of Atlas began months earlier, on the 1st of July 2025. The Asteroid Terrestrial Impact Last Alert System. Atlas, a network of survey telescopes designed to spot hazardous objects near Earth, captured a faint moving point of light in the dawn sky. At first, it seemed unremarkable, another dim intruder among thousands catalogued each year. But its orbit told a different story. Instead of looping gently around the sun like a comet or asteroid from our own family, it traced a hyperbola, a steep curve that would carry it in and then fling it back out into interstellar space. Its inclination was extraordinary, tilted about 175 degrees to the plane of the planets. In other words, it was moving almost exactly the wrong way retrograde against the solar system's traffic. This was no child of the sun. It was the 3rd confirmed interstellar object in history, after the enigmatic Oumuamua in 2017 and Comet Borisov in 2019. Atlas had been forged in the furnace of a distant star ejected long ago into the galaxy, and by chance alone it had now crossed our path. Its journey carried it toward the inner solar system, threading a dangerous course. On the 3rd of October, it would pass within 0.19 astronomical units of Mars, about 28 million kilometers, close enough for instruments orbiting the red planet to glimpse it. Already astronomers had prepared campaigns to track its light curve, to dissect its spectrum, to divine clues about its birthplace. But before Mars, before perihelion, came the storm. As the CME raced outward, Atlas was directly in its path. No interstellar traveller had ever before been tested by our sun in this way. What would happen when the alien met the plasma? We had a precedent, though only faint. In 2007, the comet Enki, one of the most ancient and familiar bodies in the solar system, had been struck by a coronal mass ejection. NASA's Stereo spacecraft recorded the moment the comet's ion tail was severed cleanly, like a scythe cutting through a streamer of smoke. Enki itself survived, but the shock was visible, a testament to the violence of the solar wind. If a native comet could be decapitated so easily, what might become of Atlas? A stranger with unknown composition, unknown strength, unknown fragility. Imagine the scene. A cloud of plasma, billions of tons in weight, surges outward at nearly 1,000 kilometers per second. Magnetic fields twist like ropes. Electric currents blaze, particles scream through space at near-relativistic speeds. Into this sea of fire drifts a frozen remnant from another sun. Its coma, a halo of evaporating gases, brightens under the lash of radiation. Its ion tail, made of charged particles streaming away from the nucleus, stretches out behind it like a pale blue banner. Then the storm strikes. The CME slams into the coma, stripping ions, twisting the tail. The banner whips shreds and is ripped away, vanishing into turbulence. For observers on Earth, Atlas may brighten, suddenly flaring as its gases are ionized by the shock. Or it may dim its tail, erased, its glow subdued. Every possibility was on the table. The only certainty was that something unprecedented was unfolding, a duel between a star's fury and a wanderer from another star system. To astronomers, Atlas in the storm was more than a curiosity. It was data precious and irreplaceable. The chemistry of its coma might reveal isotopes unknown in our neighborhood. Carbon, nitrogen, oxygen, if their ratios differed from what we know, they could point to a very different stellar nursery. The way its tail responded to the CME could reveal the density of the plasma, the structure of the magnetic field, even the microphysics of ion acceleration. What textbooks could not teach the cosmos was teaching in real time. And for the imagination, Atlas was a symbol, a lone ship battered by solar fire, a trespasser caught in crossfire, a relic from another system wandering unknowingly into the storms of ours. It was a vision that belonged as much to poetry as to science, a reminder that the universe is not kind, not gentle, but a battlefield of forces we are only beginning to grasp. The sun was at maximum rage. Its radio flux surged to 180-190 units. Its face was mottled with sunspots, black scars where magnetic knots writhed. And in this season near the equinox, the Russell-McFerran effect made the storms more dangerous still. Earth was spared a direct hit, but Atlas was not. This stranger, come from a place we will never know, was the one to pay the price. For those watching from Earth, the drama unfolded quietly, almost invisibly. Through telescopes, Atlas was only a faint smudge against the background stars, yet astronomers knew what was happening. Behind that blur, a war of particles was raging. Charged ions from the sun were colliding with molecules in the comet's halo, stripping electrons, tearing bonds, creating ghostly auroras in miniature. If Atlas had eyes, it would have seen itself engulfed in a storm brighter than any sky. Professional observatories tracked every fluctuation. Spectrographs split the light of Atlas into its components, searching for signatures of carbon monoxide, carbon dioxide, cyanogen, or water vapor. Variations in those lines would reveal how much material had been stripped, how violently the solar storm had bitten into the nucleus. Even amateurs contributed. From backyards in Chile, Argentina, and South Africa, photographers captured time-lapse images hoping to catch the subtle twist or break of the tail. Each frame, each data point added to the global record of a cosmic first, an interstellar visitor lashed by the breath of our star. To understand the uniqueness, consider what Atlas represents. Oumuamua, the first interstellar object discovered in 2017, was too faint, too fast, and too peculiar to study in detail. It slipped away before instruments could truly pin it down. Borisov in 2019 offered a better look, revealing itself as a classic comet, but one with unusual chemistry. Now Atlas was the third, and unlike the others, it was caught in a storm. Fate had given us not just a glimpse of alien matter, but a glimpse of how alien matter responds to our sun's violence. The metaphors flowed easily. Astronomers described Atlas as a ghost ship in a war zone, its pale sails shredded by invisible cannons. Others called it a messenger, a courier carrying secrets from another world, now forced to deliver them under duress. Still others compared it to a soldier tested in battle, its scars the only record of the fight. And those scars mattered. The tearing of a tail is not just spectacle, it is physics. This severing shows where the magnetic field lines of the sun slice through ion streams. The brightening reveals how quickly molecules ionize under shock. Each change is a data point. A cipher that once decoded expands our understanding of plasma magnetism and the universality of physics itself. Meanwhile, the human imagination wandered further still. What if Atlas had formed around a distant star with planets of its own? What if it had passed near worlds with oceans, with atmospheres, perhaps even with life? Now here it was, billions of years later, drifting through our system, carrying whispers of a history we will never see. and in its brief encounter with the sun, it allowed us to read just a little of that story. It is easy to forget scale when speaking of such things. The CME that struck Atlas was millions of kilometers wide, a cloud that could have engulfed entire planets. Atlas itself, likely only a few kilometers across at most, was a speck in comparison. The fact that it survived at all was a testament to the resilience of rock and ice against cosmic fire, but its surface, its halo, its tail, those would bear the marks of the storm. Like a traveller weathered by years of journey, Atlas would emerge scarred, changed, yet still moving. As days passed, observers noted subtle changes. Reports suggested a slight increase in brightness, a shift in the orientation of the tail. Nothing catastrophic, nothing world-ending, but unmistakable signs that the storm had left its touch. The sun had sneezed, and the stranger had shivered, and so the stage grew stranger still. In the span of 72 hours, humanity had witnessed 2 novas flaring like cannons in the southern sky, 2 earthquakes striking Venezuela like fists of stone, and now the sun lashing an interstellar wanderer with plasma fire. Each event alone was remarkable. Together they seemed orchestrated, a chain of chaos too deliberate to ignore. But for Atlas, the story was not finished. It would soon swing past Mars at a distance of 28 million kilometers, close enough for orbiting spacecraft to track it with instruments sharper than any on Earth. And then it would dive toward perihelion, skimming the sun at 1.36 astronomical units before arcing outward forever. What it carried with it, dust, ice scars, and secrets, was more than curiosity. It was a message, one written in chemistry and light, waiting to be deciphered. The universe had taken a stranger from the stars and thrown it into a firestorm. It had survived. But survival was only part of the story. For the greatest mystery of Atlas was not what it endured in our system, but what it brought with it from another. A message in a bottle cast into the sea. That is what 3i Atlas represents. Not glass and cork, but rock and ice drifting across the dark ocean of the galaxy for millions, perhaps billions of years, and by sheer chance it has washed up on our shore, a fragment from elsewhere, a stranger among familiar planets, offering us the possibility of a story carried across interstellar space. The question is, what message does it contain? When astronomers first detected Atlas on the 1st of July 2025, they knew it was different. Its orbit was too steep, too fast, too alien to belong to our solar system. But an orbit alone tells us little of its birth. To know where Atlas came from, we must know what it is made of, and for that we turn to light. Spectroscopy is the art of listening to the voice of molecules. When sunlight or starlight reflects off an object like Atlas, the gas and dust in its coma absorb specific wavelengths. Each molecule, cyanogen, carbon monoxide, carbon dioxide, leaves its own fingerprint in the spectrum. By dissecting that light, astronomers can identify the chemicals, measure their ratios, and compare them to comets born in our own system. If Atlas shows the familiar signatures, cyanogen, water vapor, carbon dioxide, in patterns we know, then perhaps it formed in conditions not unlike our own Kuiper belt or Oort cloud. But if its spectrum differs, if its ratios are skewed, if unusual elements appear, then we may be glimpsing a chemistry foreign to our sun. That would mean Atlas was not just a visitor from another star, but a sample of another planetary nursery, a frozen postcard from a world we will never see. The possibilities go further still. Some astronomers whisper the word panspermia, the idea that life's building blocks, organic molecules, amino acids, even microbial spores could travel between stars riding within comets or asteroids. It is not science fiction. We have already found amino acids in meteorites that fell to Earth. We know that interstellar clouds harbour complex organics. If Atlas carries such molecules, if its spectrum reveals carbon chains that hint at biology, then it may prove that life's seeds are scattered far more widely than we imagined. A simple interstellar rock could be a courier bearing the possibility of life across the galaxy. Even without biology, Atlas may carry the scars of its birth. One theory suggests that many interstellar objects are born in violence fragments ejected from stellar systems when giant planets migrate or when stars explode. Atlas could be such a shard, Perhaps it was once part of a planetesimal, orbiting a star that no longer exists. Perhaps it was flung outward by the shockwave of a supernova, blasted free into the interstellar void. If so, its minerals, its isotopes, its very structure might bear witness to that ancient catastrophe. To study Atlas is to hold a relic from a cosmic graveyard. Think of it this way. Atlas is a letter written in a language of chemistry and physics sealed in ice and delivered across light years. We may not understand every word, but we can trace its handwriting, see the flourishes that mark it as foreign as other. It is as though another civilization, or rather another star, has sent us a postcard. We were here, it says. This is what our world was like. For the human imagination, such an idea is intoxicating. We stand on a small planet orbiting an ordinary star, and yet into our neighborhood drifts a messenger from far away. It is easy to see Atlas not as a random rock, but as a story bearer. A message in a bottle, yes, but one that has drifted not across an ocean, but across the gulf between stars. And the timing of its arrival only deepens the mystery. In the span of a single week, novas erupted in Centaurus, and Sagittarius, Venezuela shook with twin earthquakes. The sun unleashed a storm, and into that storm Atlas drifted. Each event alone is remarkable. Together they feel like punctuation marks in a sentence too vast for us to read. Atlas reminds us that the universe is not closed. We are not alone in our small system. Material from other stars, other worlds can find its way here. Every interstellar object is a clue that planetary systems are dynamic, violent, and leaky. They shed fragments the way trees shed seeds, scattering them into the galaxy, where they may take root or simply drift forever. Atlas is one of those seeds. To catch it, to study it, is to glimpse the ecology of the galaxy itself. But what secrets does this seed hold? Does it carry organics whispering that life may be common? Does it carry isotopes forged in a supernova hinting at a violent birth? Or does it carry nothing but dust and ice, a mute wanderer significant only because of where it came from? We cannot know without listening, without watching, without deciphering the language written in its light. The stakes feel immense, not because Atlas threatens us, but because it invites us. It invites us to see beyond our boundaries, to imagine worlds that are not ours, to accept that the galaxy is more connected than we once believed. It is humbling to think that as we quarrel on Earth, as we marvel and fear novas and quakes, an object from another star system drifts silently above, indifferent to our concerns, carrying its own long and silent history. And so scientists continue to measure. Every photon of light reflected from Atlas is precious. Every spectral line is a syllable in its story. The coma, the tail, the nucleus, they are the pages of its message. And as we read, we must remember this is not fiction. This is not speculation. This is real matter. Real atoms, real molecules travelling from a place we will never visit into the reach of our telescopes, into our understanding. For centuries, humanity has wondered whether life is unique to Earth or spread across the cosmos. Atlas, in its silence, may contribute to the answer. Imagine if spectroscopy reveals complex organics in its coma molecules, with chains of carbon and hydrogen, the raw ingredients of biology. That discovery would not prove that life exists elsewhere, but it would make the possibility harder to deny. Life on Earth could be part of a larger pattern seeded from afar, scattered like pollen on the winds of space. This is the essence of the panspermia hypothesis, that the building blocks of life, or even microbial life itself, may hitchhike between worlds and stars. Rocks ejected from planets by impacts can carry spores into space. Comets can shelter fragile molecules within icy cores. Over millions of years, some of these fragments escape their home system set adrift in the galaxy. Most vanish into the void, but some, like Atlas, pass near other stars. If Earth was seeded this way, then life is not an isolated miracle, but part of a grand exchange, a cosmic ecology, where worlds pollinate one another. Skeptics argue that the journey is too harsh, radiation too strong, time too long. But meteorites that fall to Earth already contain amino acids. Organic molecules have been detected in interstellar clouds. The ingredients are hardy persistent, woven into the fabric of the universe. If Atlas carries them too, it becomes one more piece of evidence that life's chemistry is widespread. And if Atlas is more than a seed, if it is a shard from a cataclysm, consider the possibility that Atlas was once part of a system destroyed by supernova. A star dying in violent collapse could have blasted fragments outward, hurling them into interstellar exile. If Atlas is such a fragment, then within its minerals lie isotopes forged in a furnace beyond comprehension. To analyze those isotopes is to touch the death cry of another star, to hold in our hands a piece of stellar history written at the moment of destruction. Both scenarios, seed and shard, are profound. One suggests life's potential ubiquity, the other its fragility. One points to a universe teeming with possibilities, the other to a universe of endless violence. And Atlas may be both a seed born of violence carrying possibility within catastrophe. For now, we do not have the luxury of touching it directly. Unlike Oumuamua or Borisov, Atlas is too faint, too distant for a spacecraft mission in this pass. All we can do is watch from afar, yet even that distance is enough. Every telescope turned toward it is a reader studying the bottle washed up on the shore. We peer through glass, not at a star, but at a stranger who has crossed unimaginable distances. We strain to hear its whisper. The metaphor is inescapable. Atlas is a postcard sent from a world we will never visit. It is a letter written not in ink but in atoms, telling us about conditions that existed long before Earth's first cities, perhaps before Earth itself. It is a message that says, we are not alone in the galaxy. Other places exist. Other stories unfold. But messages can be ambiguous. The handwriting is smudged. The paper is torn. We may interpret one thing only to find another. Does Atlas say that life is likely, or that destruction is inevitable? Does it say that stars everywhere produce the same chemistry, or that diversity is richer than we know? We will debate for decades. And all of this, remember, unfolded in the same extraordinary week. 2 novas flared, 2 earthquakes shook, the sun erupted, and Atlas carried its secrets through the storm. 4 shocks in 72 hours, crowned by a messenger from beyond. To call it coincidence is easy. To feel it as a pattern is human. So we stand at the edge of interpretation. Was it chaos, random events with no link but time? Or was it a kind of code, a message written across sky, ground and space, nova, quake, storm and stranger? A chain too neat to ignore, too loud to dismiss. Atlas is the key that makes the pattern tantalizing. For it is not just a visitor. It is a reminder that the universe is larger, stranger, and more interconnected than we imagine. A message in a bottle drifting across the galactic sea, washing up just as the heavens erupted. And that brings us to the larger question, the one hanging over all these stories. If this was a code, then who or what wrote it? Nova, earthquake, solar storm, interstellar visitor, all within 72 hours. To list them in sequence is to feel the rhythm of impossibility. It sounds like the synopsis of a disaster film, yet it is the logbook of reality in late September 2025. The sky lit with 2 novas, the ground convulsed in Venezuela. The sun sneezed plasma across the solar system, and into that blast wandered an alien object from another star. Chaos or code. Imagine standing at the edge of a vast casino. The tables are infinite, the dice have countless sides, and every spin of the wheel is written in the language of physics. Now imagine 4 jackpots falling in a row. Each event alone is improbable. Together they feel like a conspiracy. A chain of dominoes toppling one after another, though no one admits to setting them up. Scientists remind us coincidence is not conspiracy. There is no evidence that novas thousands of light years away can trigger earthquakes on Earth. No mechanism links a coronal mass ejection to tectonic faults in Venezuela. Interstellar objects do not arrive on schedule synchronized with solar activity. These are independent phenomena, each obeying its own laws. The chain is in our eyes, not in the cosmos. Yet psychology tells a different story. Humans are creatures of pattern recognition. It is what kept our ancestors alive. To hear a rustle in the grass and suspect a predator, even if it was only the wind, was safer than ignoring it. Our brains are tuned to see shapes in clouds, faces in tree bark, meaning in randomness. When 3 knocks echo in the night, we imagine intention, not accident. When 4 cosmic shocks arrive in a single week, we imagine code, not chaos. Consider the examples. In 1556, a nova appeared in the constellation Cassiopeia, and astrologers proclaimed it a sign of change. In 1755, Lisbon shook with a devastating earthquake, and preachers called it divine punishment. In 1859, the Carrington event lit skies with auroras and set telegraph lines aflame, interpreted by some as a warning from the heavens. Each time humans reached for meaning. Each time we asked not just what happened, but why now? In September 2025, the same instinct flared. Social media pulsed with theories. Some called it the wrath of the cosmos. Others joked about end times, bingo, nova quake, CME, alien comet, all squares checked in a single round. Still others leaned on darker suspicions, governments hiding knowledge, agencies concealing links, scientists downplaying synchronicity. The facts remained stubborn, no causal connection, no hidden hand, but the sense of pattern refused to fade. What makes coincidences powerful is not their probability, but their timing. Spread over years, these events would be filed away as curiosities. Compressed into 3 days, they feel like a message, like hearing the same melody played on different instruments close enough in time that the brain insists on connection. The novas are trumpets, the earthquakes are drums, the solar storm is a cymbal crash, and Atlas is the violin string trembling underneath. Together they form a symphony of unease. The phrase often used is cosmic synchronicity. It does not claim causation, but connection, in perception events stitched together by human awareness, rather than physical law. Carl Jung coined the term to describe meaningful coincidence, the sense that chance occurrences may carry symbolic weight, even when causally unrelated. September's chain of events was the largest stage yet for such a drama, played not in the psyche, but across the heavens and earth. Skeptics counter with mathematics. The universe is vast and full of noise. With billions of stars, earthquakes, daily solar storms frequent, and countless minor bodies drifting through, the odds of several notable events clustering are not as small as they feel. It is like rolling dice. Sooner or later, improbable sequences appear. To the dice, nothing is special. To the gambler watching, it feels miraculous. Yet the gambler cannot shake the feeling, nor can we. The timing presses against reason. The symmetry tempts belief. 2 novas above, 2 quakes below, 1 storm from the sun, 1 stranger from beyond. The balance is uncanny. So what do we do with this? We tell stories. We cast metaphors. We call it dominoes, jackpots, drums, or codes. We try to translate chaos into language we understand. And in that translation lies both our strength and our weakness. Strength because the drive to connect events is what gave us science, the leap from apple, falling to law of gravity. Weakness because it can also lead us into superstition, seeing meaning where there is only noise. The line between curiosity and delusion is thin. To say this feels like a code is not the same as declaring this is a code. The first inspires investigation. The second halts it. September 2025 challenges us to balance on that line, to let wonder propel us forward without letting fear drag us backward. And so, we circle back to the question. Chaos or code, randomness or message, noise or pattern. We know the science, independent events, no causation, coincidence compressed by time. But we also know the psychology, humans cannot help but wonder. If this is chaos, then it is a spectacular demonstration of how rich, violent, and unpredictable the universe can be. If this is code, then it is a language we have only just begun to read. The novas were the first syllables, the earthquakes, the punctuation, the solar storm, the exclamation, and Atlas the question mark. The stage is set, the actors have played their parts. Now we lean forward, waiting for the next line. And the cliffhanger remains, if this was a code, then what was the message? The human urge to find patterns is not weakness alone, it is also the seed of discovery. Think of Isaac Newton watching an apple fall. Many had seen apples drop before, but Newton asked whether the fall of fruit and the motion of the moon were part of the same pattern. They were, and from that recognition came the law of gravity. Think of Johannes Kepler, who spent years sifting through the erratic orbits of Mars until he discerned the hidden ellipses. The universe rewards those who notice structure where others see only noise. Could September's chain of events hold a hidden structure too? Scientists remain cautious. The novas were thousands of light-years away, the quakes just beneath our feet, the solar storm born from tangled magnetic fields, an atlas and orphan from another system. They belong to different scales, different domains. To connect them is to stretch threads across vast gulfs of cause and effect. And yet history teaches us not to dismiss coincidence too quickly. The task is to test, to probe, to measure, to ask whether any faint causal whisper might lurk beneath the roar of chance. Some fringe researchers speculate about solar-terrestrial links. They note studies hinting at correlations between geomagnetic storms and seismic activity. Most mainstream seismologists dismiss such claims as statistical mirages, yet the whispers persist. Others suggest cosmic rays from novas could influence cloud formation or atmospheric currents, though the distances involved render direct effects vanishingly small. None of these ideas have clear evidence, but they illustrate how the human mind gropes for bridges between events. The impulse is not absurd. It is the same impulse that once tied tides to the moon and storms to the sun connections now accepted as obvious. But even if science never finds such a link, the cultural impact remains. The story of September 2025 has already entered popular imagination. It is told as the week when the universe spoke. Memes of cosmic bingo cards circle online. Documentaries rehearse the timeline like a countdown to apocalypse. Artists paint Atlas caught in solar fire novas blazing above earthquakes, ripping the earth below. It becomes less about what happened than about how it felt, and how it felt was uncanny, as if we had stumbled into a message we could not yet decode. Consider again the metaphor of the 3 knocks in the night. You lie awake, darkness pressing close, and then knock, knock, knock. The sound may be pipes wind coincidence, but your pulse quickens because repetition implies intention. The cosmos gave us not 3 but 4 knocks in 72 hours. It is no wonder hearts quickened. This tension between chaos and code is the essence of our relationship with the universe. We crave certainty, yet the cosmos offers ambiguity. We long for meaning, yet the stars speak only in light and gravity. We want narrative, yet physics writes in equations. And so we become the translators turning chaos into story code, into myth. Perhaps that is the true message of September, not that the events were connected, but that we are. We connect them because connection is what we do. Whether it is nova and quake storm and stranger or apple and moon, we are wired to bind the world into a whole. Sometimes we're wrong, sometimes we're right. Always we're searching. If this was chaos, then it was a chaos rich enough to spark imagination across the globe. If it was code, then it is a code without key waiting for new science to unlock it. In either case, the outcome is the same wonder. We looked up, down, and outward in the same week, and each direction shook us. The heavens flared, the earth groaned, the sun roared, and a traveller from another star crossed our skies. So what was it, chaos or code? The safe answer is chaos coincidence compressed into spectacle. But the thrilling answer, the one that keeps us watching the skies, is code. A message not yet translated, a story not yet finished, a whisper from the universe itself. And the whisper lingers unresolved. If this was a code, then what was the message? It may all have been coincidence. The novas flaring in the southern sky, the earthquake striking Venezuela, the sun releasing a storm of plasma, and the interstellar visitor wandering into the fire, all of it may have been nothing more than the dice rolls of a restless cosmos. But coincidences like this do not pass quietly. They linger in the mind. They press us to think. Picture the scene as it unfolded. In the south, new stars seemed to bloom over night novas blazing like cosmic cannons. On Earth, buildings shook, chandeliers swayed, and families rushed into the streets as the crust groaned beneath them. Overhead, the sun exhaled a billion-ton cloud of plasma magnetic fields, twisting outward like fiery ropes. And far beyond, a traveller from another star crossed through the storm, its tail ripped and reshaped. 4 shocks in 3 days scattered across domains, yet united in memory. Science insists these events are independent. No nova could trigger an earthquake, no quake could summon a coronal mass ejection, no solar storm could conjure an interstellar rock. The distances are too vast, the mechanisms too separate. Each is an island of causality connected not by physics but by coincidence. Yet the fact that we witnessed them together is still meaningful. It reminds us of the fragility of our place, the smallness of our species, the razor-thin layer of calm that separates us from chaos. For the people of Venezuela, the message was immediate. Homes shook, cities trembled. The solid ground revealed its instability. For astronomers watching the novas, the message was equally humbling. Stars can erupt without warning, pouring out energy that makes human achievements feel like sparks from a campfire. For engineers tracking the sun, the message was one of vulnerability. A storm strong enough could disable satellites, collapse power grids, and plunge modern civilization into darkness. And for those studying Atlas, the lesson was cosmic perspective. Our system is not closed, and visitors from beyond can arrive at any time carrying secrets we cannot anticipate. 4 domains, 4 warnings, Earthstar, Sun, and Stranger, all reminding us that the universe is not gentle. It is dynamic, unstable, and indifferent to our schedules. The timing may have been coincidence, but the message we take from it does not have to be. Throughout history, humanity has wrestled with coincidence. Ancient cultures read them as omens. Philosophers debated whether fate or chance governed the world. Today we rely on science, and science tells us these events are not connected. But science also tells us that to ask questions in the face of mystery is not folly, it is progress. Gravity was discovered because someone asked why apples fall and moons orbit. Electricity was harnessed because people asked why lightning strikes. To see a chain of events and wonder if they are linked is not superstition. It is curiosity. The difference lies in what we do next. Do we stop at fear, or do we test, measure, and learn? The week of chaos teaches us that the line between order and disorder is thin. The earth can convulse without warning. The sun can roar without concern for us. Stars can detonate on timescales longer than our history. And yet here we are, fragile and small, but capable of noticing, of recording, of asking. That capacity is what makes us different. Hope is what makes us different. Think of Atlas again, drifting through plasma, scarred but still moving. It is not alive, not aware, yet it carries history across the galaxy. We, unlike Atlas, can read history. We can wonder at it, fear it, and learn from it. We can transform chaos into knowledge. That is the gift of being human. And so we take lessons from coincidence. The lesson of humility: we are small beneath novas, earthquakes, and solar storms. The lesson of resilience: though fragile, we endure and we keep watching. The lesson of curiosity: questions are not errors but engines. The lesson of meaning: even if the cosmos offers no code, we can write one ourselves, crafting hope and direction from the silence.